Hi everyone, my name is Rebecca. I'm a fish biologist and ichthyologist and also a PhD student. I specialise and study the evolution of loricals, catfishes, also known as plecos within the aquarium trade. And along quite similar lines to many of the topics I discuss, I'm going to talk about fish diets and particularly ornamental fish diets, so aquarium fish diets basically, in the context of the fishes we're actually keeping. So it's kind of long been recognised that aquarium foods actually need to change, and ornamental fish foods in general. Much of the fish feeds we're using are actually based on science and aims towards aquaculture. So the main difference here is largely aquaculture, which is farming fishes, and particularly food fishes is the most common. They want efficiency, so a food that will give the largest fish in the least amount of time possible for the least cost. Which might sound okay as an aquarist, but this is actually very short term. Often they want the fish only for maybe a year tops, but usually a few months. So the actual long-term health isn't as much of a concern. Neither is breeding the fish as much, and neither is coloration or anything like that, because if you're going to eat the fish, it doesn't really matter how it looks afterwards. But that's what a lot of our fish diets are based on. And if you look at the ingredients, it's very similar to a ground bait if you're fishing, or just food fish feeds in general. So it doesn't actually reflect what we need or what we want from ornamental fishes. The other aspect is when it comes to ornamental fishes versus aquaculture and food fishes, is we're dealing with very different species. Food fishes or feed fishes tend to be very generalist fishes that can eat a wide range of things and not really have an issue in the short term. Stuff like tilapia, channel cats, salmon trout really, anything kind of along those lines. Whereas we're dealing with, I think the best sort of models are kind of like cardinal tetra, pterophyllum, so angelfish, and then for like algivores, stuff maybe even loricals, and there isn't a few literature sort of papers on either of those. And we do know that the actual diets differ a lot in the wild from what they're being fed, but also there are potential long-term effects. So what other factor, like when we're considering ornamental fish foods, what do we have to think about? A big thing is actually the diversity of species we deal with, and therefore this is a diversity of different diets. So we're dealing with many different genera, families of fishes, so not just one sort of family or a few examples from very narrow number of families. And yeah, so the diets will differ between different groups, different clades, but also between species within the same clade. So a good example of this would be cichlidae. So cichlidae, cichlids, they are traditionally, most of them are like carnivores. Some are more generalist than others, but we do have examples of herbivory, so more along the lines of discus fishes or araru, and then maybe different lines of omnivory, which would be, I guess, sevums to a degree, even probably araru maybe, but the araru probably maybe not. But there's diversity of different diets between different species, and therefore you're kind of sort of generalising clades, but you've also got to balance out because not all are representative of that idea. And the same is said for loricals. Most are algivores or detritivores, but we do have carnivores. Catfishes, most catfishes are carnivores, sort of very generalist, but then obviously you've got loricaldae, the plecos, which are not. And even carnivory differs massively, and just because some things are carnivore, it doesn't mean they all eat the same thing. Some will specialise more in invertebrates, and certain invertebrates may be insects. Some might specialise more in crustaceans, some might specialise more in mollusks, and then some might be piscivores and specialise in fishes. So realistically, we're dealing with a wider variety of diets than aquaculture, and basically what our fish feeds are meant to do in a way. Our fish feeds are meant to solve sort of a very general diet, which our fishes don't fit into. It's kind of fitting, I don't know, a foot into a glove sort of thing. It doesn't quite work entirely. You can't just offer loads of different dry foods when most of them, or just foods in general, most of them contain the same thing. So you're not hitting different nutritional like niches, but also going to be eating stuff that might not be good for them because it's not part of their natural diet. So what can you kind of do about it? Well, what can you do about it? And that is research. So you can look at gut analysis studies are really good. Realistically, you kind of want to look at the scientific literature, particularly, because unlike a lot of aquarium sources, they have to be cited, they're fact checked, they have to provide, like, they have to back up their point. A lot of aquarium websites, there is a massive problem with lack of fact checking, so information can be sort of like parroted around and no one quite knows where it came from, and it doesn't mean it's true. And it's like discus being sold as carnivores, even though we know they're not, mostly feeding on algae, detritus, few invertebrates. I still wouldn't say omnivory. And then there are also fluorocarbs, where you'll see many get listed as carnivores when they're not, if you look at the scientific literature. And scientific literature can be difficult to sort of read and understand. So I've got my website if people are interested in that, and that's got a few breakdowns of different fishes, but not that many. There's all sorts of reliable websites as well. Or just sometimes you just kind of have to use a little bit of critical analysis. But you ideally want to be looking at gut analysis studies of wild fishes, not of captive, because there are multiple cases like Corydoridinae and I think some different cichlids where the actual scientific literature only talks about what they were fed in captivity and therefore they must feed on it in the wild, which is not true. Animals eat totally different things to maybe what they should do in the wild. Therefore look for wild studies, and also isotope studies can be really useful there. The other thing you can do, and this it kind of is a lot more of a sort of a critical analysis skill, is actually looking at the anatomy of the fish, and that will help you understand what its potential diet is. So this can be mouth positioning, that will give an idea of the direction of where it's feeding, whether it's feeding on the surface, in front of it or below. Head shape can give an idea of whether it's predatory, feeding on like a piscivore, or maybe it's feeding on invertebrates, whether it's going through the substrate looking for invertebrates. So the head anatomy kind of gives the biggest clue for things like the earth eaters have a very typical sort of mouth shape, and you can convergently look at it with many other cichlids. I think discus are great for this because their actual anatomy in general is almost the same as Tropheus. A lot of people might say, oh, but they're round. Ignore that. The fact they're round has nothing to do with their diet, really. There's so many factors on why a fish is shaped, the whole thing as it is, but that sort of head area and then the jaws and stuff kind of hint what they're probably feeding on in the wild. And this is very convergent with like Tropheus. Also I think silver dollars, where they've got a very strong sort of lip, very sort of poor pharyngeal jaws, so that secondary pair of jaws, they're not very good at chewing on the hard items which you'd expect in sort of carnivores of any kind. Unless they're for herbivores, maybe if they're feeding on seeds, they're going to have quite strong jaws. So looking at anatomy in general, and that's how you can apply maybe what you know about other fishes to another fish. So there's plenty you can do without going into scientific literature, but really you should do, because fact checking is so important. There's so many myths that get spread. So kind of what basic nutrients are there, and I've written an article that kind of goes over the basics of this. There's quite a few different myths about this. So the main ones are protein, carbohydrates, lipids, vitamins and minerals. A big one I'll say first is minerals are really important, and they'll be listed as the ash content. Now, ash content isn't physical ash, it's what happens if you burn the food down, removing all of the organic matter, and it just leaves the mineral content. That is the mineral content. It's not ash. They're not adding potash, they're not bulking it out. All diets have an ash content. They might not list it as an ash content. Doesn't mean they're adding ash. So there's many different minerals that are needed. You've got like calcium and magnesium. Calcium can be obtained partially through the water, and I believe magnesium too, but the levels depend on the individual fishes we're talking about, where they come from, and also their own sort of evolutionary history. So you can kind of assume those from sort of low conductivity waters will be taking much more of their calcium and magnesium up through their diet, opposed to very hard waters where it really will be a little bit more flexible because they've got the option of what's in the water itself. But there's many different vitamins and minerals from thiamine, vitamin B1, which is why you avoid diaminase, avoiding any raw mussels or raw certain seafood ingredients. They should really be cooked to remove that diaminase, but they're still deficient in this vitamin. There's also B12, which differs between different fish, whether they need it supplemented or not. You'll see it in many different fish diets for that reason. But the big nutrients a lot of people think about is protein. Protein is important. It builds many different structures within biological organisms, or just organisms I guess, because all are biological. So protein is important, and what is also important is where that protein comes from. Not entirely because the protein's different. The different building blocks, the amino acids that build up the proteins can differ. So plant sources tend to be a lot more limited in certain amino acids, whereas sort of what, like animal proteins can have different sort of structures and therefore different amino acids. So that sort of balance is going to be based on what you know about the fish's diet and replicating that as close as possible. But also, because I mentioned vegetables and sort of plants, that doesn't include algae. So the ones, a lot of the amino acids that plants are deficient in, algae do actually kind of have, or it depends on the algae. The other factor about this is digestibility. If they are not evolved to feed on that source of protein in the wild, they will not be able to digest it as well, and they will not be able to process it as well. So that even goes for carnivores, where fish meal won't be processed as well as an insect meal for an insectivore, but there is a little bit of diversity there. So it's a lot more complex, and realistically, to put it simply, look at what the fish feeds in the wild, and the source of protein should be what they eat in the wild. And just because you think something's photosynthetic and therefore low in protein, it doesn't mean it is. Algae are quite high in protein, and just one species of algae can replace a whole sort of aquaculture food. So imagine what imagine what a diet of a mixture of them does. And this wasn't even a long-term study, particularly long-term I guess. But that's just one species of algae with nothing else in it. I think they've just made into pellets. So the other things is protein. Too much protein results in more ammonia because it's just being wasted, or urea. Depends on the fish, depends on the conditions sometimes. And you've also got the factor of too much protein can affect how the uptake of other nutrients occurs. It's quite an expensive energy source. Like, it's really difficult to process as an energy source. So too high protein could actually really be an issue. Beyond, I wouldn't really talk about protein as much in terms of bloating. It's more the source of the protein, because those ingredients are probably what's really difficult for that fish to process. So lipids, another source of energy. I think they're more important for ornamental fishes than we know, but they also, like many ingredients that might not be so ideal, they can put a lot of pressure on the liver, as can carbohydrates. So you could get fatty liver disease in fishes, or just liver disease in general. So for carbohydrates, cereal crops, certain cereal crops, I think soya particularly can cause liver issues, and it depends on the individual species of fish. Mostly studies on aquaculture fish, so it's really difficult sort of to judge. And well, yeah, so carbohydrates, I think they are the biggest one used to actually bulk out foods. Sometimes I put something like peas in them, even though they're more of a source of cheap vegetarian protein. Because sometimes I think it's working on this idea that if you add, if it's a herbivore, vegetables are the same thing. It's like if you've got any mammal that's a herbivore, you know that they don't all eat the same thing. You don't feed hamster food to all of your herbivores, or you don't feed guinea pig food to your hamsters. There's so much diversity in fish water. It's very different from the terrestrial environment. So why do we need change? Other than what I've said at the start, being it doesn't replicate the wild fish diets, it's very much a longevity thing. We don't know how long some of these fishes can live, and the studies that are backing up traditional diets, traditional brands and stuff like that, are only short-term studies on the fishes that we don't keep, or often keep, unless you keep koi. And then it's like, we want our fish to breed, but we want long-term breeding. So in an aquaculture environment, you might be happy with your fish breeding once, twice, for a few years. In ornamental fishes, especially long-lived fishes, we want them to breed 1 year, next year, and just as much as we can sort of get them to breed. And some fishes aren't actually, they're like, reproductive lifespan is much shorter than even their half sort of midlife. And that's not biologically really good, or it doesn't, like, particularly for males, but spermatogenesis should be happening constantly. The quality of the sperm will decrease over age, but it shouldn't be totally stopping midlife for the fish. Females are kind of a little bit different with oogenesis, so eggs. So that is probably one of the biggest effects on diet. There is also other than, so reproduction, the big one is probably health. So what a lot of us can't see if we're feeding a fish an unhealthy diet is the liver. So the liver seems to be the organ that is most affected by an unhealthy diet. Like with a lot of mammals in general, you can get enlarged livers, it can develop unusual anatomy, it can get more fatty and show liver disease, but we don't really see because we don't open our fishes up, and it can affect how long our fishes live for. So just health in general, the liver is the sign that the fish is maybe not having the healthiest diet. And don't look at colour. Colour only, it's a very broad sort of idea of how sort of healthy the fish is. There's plenty, most diets contain red enhancers, so it's pretty unreliable in that context. And it can show stress, but also it just does, like with the red enhancers and different factors that affect fish health, colour kind of is a little bit indirect. But for the fish's health, we know that a diet that is more natural to them and is more close to what they feed on in the wild is incredibly important. We do keep still a lot of wild caught fishes who have not been able to adapt to a different diet. Many of our fishes to adapt to a different diet would take hundreds of generations. It would be a long evolution, and especially their anatomy isn't changing. The only thing I think that's changing is somewhat like jaw anatomy slightly, where they're eating softer diets than they would otherwise, and it might also be affecting their teeth, because we traditionally think about puffers when their teeth are overgrown, but a lot of other fishes like pharyngeal jaws will have that replacement of teeth, and if they're not being sort of forced to replace them, what's happening? Like, are those teeth overbuilding? I don't know. I have no idea. I've never looked into it. So I think it really varies a lot. But anyway, I've been talking for a long time. We now kind of have a Discord server, so it's kind of partially shared with my website's Discord server. Well, it is the website's Discord server partially, but to discuss sort of different topics, so new papers can get posted here, if people want to kind of keep aware of any new papers, or even old interesting papers that people have found. Obviously there's plenty of space for discussing different topics, so like different channels going across different taxa, probably forgotten a few, different regions, different water types, and sort of this is sort of where I can post all sorts of different things, so where some topics might be worth discussing, like particularly like ecology and stuff like that, and there will also always be the references if people are interested on where the sources of the information are actually from. So if people want to join, it's up to you. It's a great community, and it's aimed at being more scientific and understanding sort of the background behind topics, and going into more complex details when it comes to fish keeping, rather than going over the basics or covering sort of beginner topics. So anyway, if you like my videos, please comment, like and subscribe, and goodbye.